Okay. For this video, I'm going to discuss about distributed forces or centroids and centers of gravity. So what's the difference between centroids and centers of or center of gravity? Okay, let us see this picture. Okay. Sa left side, ang center of gravity. Ang sa right side, kanina point is called the centroid. So what's the difference here? Now, centroid is defined as a point about which the entire line, area, or volume is assumed to be concentrated. Okay? Line, area, and volume. While center of gravity is defined as a point about which the entire weight of the body is assumed to be concentrated. So it means that centroid is related to the distribution of length, area, and volume, while center of gravity is related to distribution of mass. So let us first consider the center of gravity of a two-dimensional body. Let's consider a flat horizontal plate as shown in the figure below. Okay, so flat horizontal plate. Okay. So we can divide the plate into n small elements. And the coordinates of the first element are denoted by x1. Like for example, if this is the first element, i-denote na to ang distances niya x1 and y1. And then for the second element, another differential element, delta w, i-denote na to ang distances as x2 and y2, etc. The forces exerted by the Earth on the elements of plate will be denoted respectively by delta W1, and then for the second element, delta W2, and so on, up to the last element, delta W sub n. These forces or weights are directed towards the center of the Earth. However, for all practical purposes, they can be assumed to be parallel. The resultant is therefore a single force in the same direction. So, of all the differential elements, ang resultant niya is this one. A single force in the same direction towards the center of the Earth. So, ang location aning resultant W will be at the center of gravity. Okay. Ang distances niya, x bar from the y-axis and y bar from the x-axis. So the magnitude W of this force is obtained by adding the magnitudes of the elemental weights. This one. Yeah. So summation of forces Z equal to W equal to delta W1 plus delta W2 and so on up to the last differential element, delta W sub n. So to obtain the coordinates x bar and y bar of the point G, where the resultant W should be applied, we write that the moments of W about the y and x axis are equal to the sum of the corresponding moments of the elemental weights. So, ang moment aning W about the x and y axis will be equal to the sum, the moment of this one plus the moment of this, the elemental weight, and this one up to the last elemental weight. So summation of moment about the y-axis, this one, And then we can summarize this one. X sub 1 delta W sub 1 plus, we can summarize this one by this expression. Summation of X delta W from 1 to N. The same with summation of moment about the x-axis, y bar, and then summarize the right side equal to this. So, if we now increase the number of elements into which the plate is divided, ang resulta is mo decrease ang size sa element ba? If i-subdivide pa gid nimo further, mo increase ang number of elements, but then ang size niya mo decrease. We obtain in the limit as the size approaches 0. Okay? It's too small. So we obtain in the limit the following expressions. That W is equal to the integral of the differential weight, okay, PW, and also with this intrinsic. X bar W, instead of summation, replace it by integral sign, X times dW, and also with Y. Y bar W equal to integral of Y dW. So this will be the formulas that we are going to use if we will use method of integration in determining the weight or locating the centroid. Okay? Now, we are going to use these expressions in determining the centroid of areas. Now, in the case of a flat homogeneous plate of uniform thickness, the magnitude delta W of the weight of an element of the plate can be expressed as this one. Okay? Properties of material, weight is equal to specific weight times volume. Okay? And volume will be area times thickness. So for a differential element, differential areas. So gamma is the specific weight of the material, T thickness of the plate, delta A area of the element. So pag uniform thickness and constant setting specific weight, instead of weight, we can consider the area. Okay? Kaya constant man ito, gamma and T. So similarly, we can express the magnitude W of the weight of the entire plate as this one. Kung i-add na to tanan, for all the elements, amount yan total. Substituting for delta W and W in the moment equations and dividing throughout by gamma T, we obtain this one. Mamani, di ba? X bar A. Instead na W, area na lang. And again, if we increase the number of elements into which the area A is divided and simultaneously decrease the size of each element, we obtain in the limit this one. Bali, supposed to be W, ba? W. So, this one. If W is replaced by gamma T times A, okay? So, this one, okay. If we replace this one, A will be equal to integral of dA, and then X bar A, integral of X dA, and then Y bar A, integral of Y dA. So if we use the method of integration, this will be the formula that we are going to use. So these equations define the coordinates x bar and y bar of the center of gravity of a homogeneous plate. The point whose coordinates are x bar and y bar is also known as the centroid C of the area A of the plate. This one. Okay. So area lang, this is for the individual element, and total area, and nadiri ang centroid. So pag integration, kini na formula ang gamiton. For the method of integration, there's a separate, I have a separate video on how to solve problems, on how to locate centroids of plane area. Just watch those videos. Let us know the centroids of common shapes of areas. Triangular area, for this one, y bar lang. 1/3 sa altitude. But for a right triangle, nata x bar, 1/3 sa base. Ang reference is ang right angle. The area is 1/2 base times height. For a quarter circular area, this one, most of niyang values, centroid x bar, y bar, and then area. 1/4 sa area sa square. For a semicircular area, this one, y bar lang because axis of symmetry ang x man. So ang centroid is located along the y-axis. So ang x bar na to 0. Y bar lang, same ra y bar, and then area 1/2 sa area sa circle. Quarter elliptical area, this one, x bar and y bar given, as well as the area, pi AB over 4. Semi-elliptical area, this one. Again, due to axis of symmetry ang x, 0 ang x bar. Y bar lang, and then area there. And then we have semi-parabolic area, this one, and parabolic area. And then parabolic spandrel, ano yung centroid niya? Always remember our reference, like 3/4 of A is referred there sa vertex. Okay. Vertex man eh. And then 3/10 of H is there yung reference. So for X bar, 3/4. So kung i-refer nimo diri sa corner, right angle, 1/4 of A. The area is 1/3 base times altitude, 1/3 AH. For a general spandrel, N is any value more than 2, okay? Greater than 2, most na yung X bar. And then Y bar, and then area. So make this one as your guide every time mag-solve ka of problem. Yeah. So our focus now is on composite plates. Okay. So consider an area A such as the trapezoidal area, this one, which may be divided into simple geometric shapes. So when you subdivide a composite area, okay, make sure na ang triangle nimo is a right triangle. So ang pag-subdivide is this one, and then this one. So there will be 3 elements, no? Area 1, area 2, and area 3. pwede sad na dili ka magbuhat. Draw kag line, hiya, line. And so you will have this one, a rectangle minus triangle, and then minus triangle. Okay? So for the whole area, nadiri ang centroid. Distances niya x bar and y bar. And for each element, ay una centroidal distances na. X1, Y1, X2, Y2, X3, and Y3. Always remember na katong sa basic shapes, katong centroidal distances na to, nato a certain reference. Like for example, for area 3, triangle, Y bar is 1/3 sa H. But then our Y3, diri sa pag-substitute sa or pag-solve sa Y bar, our Y3 is not only 1/3 sa H. We still have to add this one, the height of element 2. Okay, remember na all distances must be referred sa coordinate axis. So pag Y, it's referred from the x-axis. Pag x distance, it's referred from the y-axis. Like for area 2, we all know na ang centroid sa rectangle is at the geometric center. But then our x2 is not only 1/2 sa base. We have to add the base of the triangle sa element 1. Kaya nga itong x sub 2 kay kini man gikan sa centroid to the y-axis. So that would be 1/2 sa base sa rectangle plus base sa triangle. So that's one possible source of error pag dili ka mag-add sa base sa triangle. So you need to focus in determining centroidal distances. So to obtain the coordinates x bar and y bar of the centroid YC of the composite area A, we have this one. Okay. And for x, this one. And solving for x bar and y bar and recalling that the area A is the sum of the component areas A sub I, we write so x bar and y bar are the coordinates of the centroid. Okay, let us solve some problems. Locate the centroid of the plane area shown. Okay. So this is our plane area. Okay. First is we need to subdivide this one into basic shapes. So ang pag-subdivide, as much as possible, dapat least number of elements. Okay. The least number of elements is 2, this one. Rectangle and triangle. Pwede sad na rectangle, this one, minus another rectangle, minus triangle, pwede sad 3 elements. No? Same result. Same value sa x bar and y bar. Okay, so let's consider this one. Element 1 and 2. So area 1 and area 2. Now, para systematic ang solution, let's construct a table. Okay, so the table, ang first column will be for the number of elements, and the next is area, and then x distance, y distance, and then this one is product sa x distance and area, and then this one product sa y distance and area. Take note, all distances must be referred sa coordinate axis. Okay. For element 1, the area is this one, rectangle. Base times height, so it's 20 times, this is 60. 36 plus 24. It's 1, 2. And in element 2, triangle, it's 1/2 of base times height. So it's 1/2, 30 times 36. That's 540. So i-add na to. Summation of area, it's 1740. Okay. Distances, x1. Ang center sa element 1 nasa geometric center sa rectangle. Okay. So, muna ito x1. So, it's obvious that this is equal to 10. 1/2 sa 20. 10 siya. And then y1 is this. 1/2 sa 60, which is 30. So, 30 na. For element 2, ang centroid na dali. Now, this is our x2. Now, sa basic shapes, 1/3 na siya sa base. Our base is 30, so 1/3 na is 10. But we have to add 20. Kaya ang reference is sa y-axis man. So this distance will be 10, 1/3 to 30, 10 plus 20, which is 30. 13. And this is y2. Now, this distance, basic shape sa triangle, this distance is 1/3 sa height. 1/3 of 36 is 12. We need to add this one, 24. Oh. So it's 12 plus 24, that's 36. That's it. After this, multiplication na lang. Xi times A is 1, y times A, and then x times A, and then y times area. And then i-add, na 36,000 plus 19,440. So, solving for the centroid, summation of XIAI is this one. Moment ang total sa XIAI. While summation of A is 1740. And X bar is 16.207 millimeters. Y bar, summation of AI is this. And our Y bar is 31.862 millimeters. So for composite figures or composite area, ang pinaka-importante is this one. Determining the distances. Pag wrong ang isa wrong sa dan. Erroneous sa di mong final na answer. Another problem. For the area shown, use composite shapes to determine the X and Y positions of the centroid. Now, first, let us subdivide the plane area. So, this one. So, we have a triangle, we have a rectangle, and we need to subtract this one, quarter of a circle. So, cut na to. So, element 1 na to is this square, no? Base there, the dimension is 30 by 30, 10 plus 20. So, it's a square plus this one, triangle, and minus quarter of a circle, a something. So let us have this table. For element 1, it's area 1. It's 30, this one 30 by 30. 900. Element 2 is triangle. That's 1/2 of 30. This is 30. And this one is 10. So, ang 10 is this. 20. 20 plus 20, 40. 30 man sa left. So, i-subtract nimo 10 siya. 10 siya. It's 1/2 of 30 times 10. 150. And then element 3 is quarter of a circle. Pi over 4 times r squared. Minus 1/2, 1/4 niya times pi niya radius squared. So i-add nimo 900 plus 150 minus 100 pi. The result is this. Okay, xi. Xi by element 1. Another yung centroid, geometric center. Yeah. Okay, so xi of course is just 1/2 of 30. This is 15. 15. Yeah. And then ang yi 15 also. 1/2 sa 30. 15. For element 2, centroid is nakagali. Okay. This is 2/3. Kasi triangle, 1/3 mo eh. 1/3 sa base. So this is 2/3. 2/3 of 30. That's 20. 20. Y2 is this one. 1/3 sa, this is 10. Andrea. 20 plus 20, 40 minus 30, it's 10. So this is 10. 1/3 na. 1/3 sa 10 plus 30. 30 mo na, no? And it's 33.33. And then for element 3, quarter of a circle, the centroid of a quarter of a circle is this one. 4r over 3 pi. 4 times r over 3 pi. But then, ang reference ani is a corner. So this will be 4r over 3 pi, and this is also 4r over 3 pi. But then our x3 is this one. So what's the value of this? This is 4r over 3 pi, or simply 8.49. Therefore, this distance is equal to 30 minus 8.49. And that's 21.512. Okay. But ang y bar is equal to 8.49. Okay. 4r over 3 pi said na. So after this, just multiply. Xi times A, yi times A. Also with this, and then element 3. After that, i-add mo. This is summation of xi, ai, and then this one also. So we are now ready to determine the centroidal distances. Okay, and then x bar is 13.24. And for y bar, this is the formula, and then substitute values. 15,833.33 divided by area. 21.52 millimeters. Okay. Another problem. Locate the centroid of the plane area shown. This one. Okay. So, okay. Let's have this one. Actually, the shaded area is equal to this one. A semi-parabolic area minus triangle. So, we have two elements, semi-parabolic area and then triangle. Okay, so this is our element 1, semi-parabolic area. Now, the area is this, semi-parabolic area. Ganyan. The area is 2/3 AH. 2/3, 75 times 120, 6,000. Now, yung centroid is, okay, based sa table, ang centroid sa semi-parabolic area for x bar is 3/8 of A. Remember, na nadiri ang vertex. Okay, nadiri ang vertex. So, x bar na. Tapos kana is y bar. Y bar. From the vertex ang side na adjacent niya, y bar. Okay. So, now this is the vertex. So, this will be y bar sa table. And this is x bar. 3/8 of A. 3/8 times A. So, 3/8 times 75. That's 28.125. 3/8 times 75, that's 28.125. Now, for y bar, take note dire, ang y bar is referred sa vertex. From vertex to centroid. That's 3/5. 3/5. Okay. 3/5 of 120. Okay. From the vertex, this one is 3/5. But then our y bar is this. Sa table, our y1 is this one. From the table, this is y bar. 3/5. Okay? Again, 3/5. 3/5 of h. So, how much is 3/5 of 120? 72, ba? 3/5, 0.6 of 120, 72. Therefore, our y1 will is 120 minus 72. And that is 48. Okay. So, again, the shaded area is equal to the semi-parabolic area minus triangle. And this is our area too, triangle. Okay. The area is 1/2 of 75 times 60. It's negative 2,250. Minus, and then distances. This is 1/3. 1/3 sa base. 1/3 sa 75 is 25. And then y2, 1/3 also. 1/3 sa height, 60. 1/3 of 60 is 20. Okay, so after this, multiply lang. Xi times A, summation sa area, summation sa area. And the next is this one, Xi AI, Yi AI, and then for element 2, Xi times area, and then Yi times area. And then you add, and then also this one. Yeah. So next is we are now ready to locate the centroid. X bar is 30 millimeters and Y bar 64.8. So if you want to check this, your answer, you can use integration. You consider a vertical rectangular strip and ma-check nimo, ma-determine nimo if our answers are correct, X bar and Y bar. So I hope that you have learned something about composite, about determination of centroid using composite area na method. So thank you for watching.